Now I will explain the name, bias, and variance trade-off. Let's go back to the example. There is ground truth function, and there is some observations for training your model. And let's say you use a linear model, beta 0 plus beta 1 x as your target model. So you want to find the beta 0 and beta 1 parameters so that the mean squared error can be minimized with your training data point. And then the solution may be this, right? But the linear model cannot learn these curvatures, and because of the model limitation, there is some bias. So this is called bias error. The expectation of fx minus fx square is equal to something, and that basically comes from the model limitations. Okay. Then what is the variance error? Let's consider a very simple example. There is only one single input predictor and one single output predictor, and we have 4 data points for training your model. And let's say your target model f hat x is equal to beta 0 plus beta 1x plus beta 2x squared plus beta 3x cubed. And let's imagine you can get 2 data sets, and the 2 data sets are generated from some random process from the same ground truth function fx. This model generates 2 training data sets with 4 different data points. Okay. With this target model, maybe the first result is this, and the second result will be this. With this third order polynomial, we can have almost 0 training error, and that will be the outcomes of your training process. But when you compare these two curves, lead curves, the trend curves, you can see a huge difference, right? Especially for this area. The right-hand side is almost positive infinity, but left-hand side is almost negative infinity. There's a huge difference. So according to training samples, it is very sensitive with this third order polynomial model. But what if you use a very simple linear parametering model? Then for both scenario, your result will be like this. Almost same. Okay? So usually with simple model, the variance because of training data point, randomly generated training data point is small. But as you increase the number of parameters, or as you increase the complexity of your training model, then you will observe some huge variance because of the randomness of your training data point. So that's why the name of this error is variance error.